Hey guys, just gonna make a little weirdness here for world, I guess Earth mechanics, I guess would be, for you people out there that bend your minds to think that way, hard time. Anyway, today's date is May 7th, 2017. I've been contemplating and debating Earth mechanics for a long time, and anytime I heard something that made sense and inside physics, we'll say, in regards to that stuff, I just kind of pieced together and tried to think outside the box on that stuff as well. So anyway, I use an angle first off, an angle that to say, think of an old 33 LP album, and it's turning in a circle, obviously, and all the words, the beats, and the notes are all stars. And the center where the pin went through is the what you would say black hole of the universe, and all the outskirts of that would be the universe, and it's turning in a circle. And then on the other side of that, where they say there's nothing, because I don't really believe that there's nothing on the other side of whatever they want to call the Big Bang, but whatever, is another identical, well, not identical universe, but, or I guess you would call that um, universe. Yes, but it's two universes, which then would be, I would say, not universe, but galaxy. That's the word I'm looking for, yes. So we're in a galaxy. On the other side of our galaxy is another galaxy, which makes up the universe. So anyway, because of the way I see physics working at that end somehow. So, so with that being said, all the bigger stars out there, and they want to say this and that about stars burning out. Well, I have a theory about that. That all these stars, they say, lead down to giving off one gas or whatever, one particulate. But I believe it's way more than just one. And all these stars are filling up the galaxy, we'll say, with particulate. Yes, and this particulate is being collected by the stars at the same time. So it's always refueling itself, and you get pieces that break off from here, from there, from collisions and whatnot. So, and they're always flying into the suns and well, other planets as well. But so the suns are always refueling themselves. So I'm not real sure exactly how a sun can actually cool down enough to actually do what they say they do in inside their I guess theory, I guess, because any fire I've ever seen never really expanded anything, it just burned out. So besides the point, I guess maybe something to do with the millions of degrees inside at the center of a star. But besides the point, yeah, so Um, yeah, I believe that the stars will just never ever deplete because they're always refueling themselves, always. And if one, say, then say our solar system alone, with Earth existed. So our sun picks up enough trash from space, we'll say, that it gets too heavy on its axis. Now, I'm not sure what that looks like, but that's a potential, way more than a potential. So, yeah, so what you don't see is potential of Earth-size rocks, I guess, floating into the sun's path and just becoming a part of the sun somehow. Anyway, once it gets too heavy, uh, its poles shift because it's, I guess, would be, I would say, spinning too fast or too slow. I'm not sure how that looks, but I would say that its poles shift because it's weight factor, and then um, it either speeds up or slows down from that pole shift. And then depending on which it's doing is dependent on the rest of the planets out through the solar system. Now, yeah, I believe somehow that our pole shift, when it comes to magnetics, is reliant on what the sun is actually doing in its poles. So yeah, and that being said, with the gravity and magnetics working together, because I'm thinking somehow they have to be considered as one field, not just because they're not separate from each other somehow. Because magnetics is inside gravity, we'll say. So because of that, once the poles shift in a planet or a star, whichever, doesn't matter. One effect would be to slow down because of the way magnetics is pulling on gravity. And then if it shifts the other way, it would want to speed up because the way magnetics is pushing on gravity somehow. I really can't tell you what that looks like on paper, but that's what it looks like in my head. Um, and that's because apparent somehow 2 to 3 seconds loss of rotation every 100,000 years, and certain duration in between polar shifts. Now, like I said, no one's going to get to the sun to tell if the poles shift at the time our poles shift, but I believe it's coming quicker than we think somehow. And they do say that the poles have shifted. The magnetic poles now have shifted over time, and I believe somehow it's going to have something to do with what they classify as global warming, which is, again, is a crock of crap to me somehow, because it's an Earth cycle, and what's going on there to me is the Earth is heating up. Yes, we are helping it, but we're not causing it. It's a cycle, because this whole thing about carbons. Well, if the heat loss gets to space, and it does, so do the carbons. So it's like whatever they want to tell me is whatever they want to tell me. So that being said, we'll take the term called geez, I just said it. Because I don't believe in it, so that's why it's slipped my mind again. Oh, global warming, yes. Global warming. So it's not really a theory. It's more of a statement, and exactly when it's going to happen is not sure, but it doesn't really matter, because it's going to happen. That's the thing. There's two channels, two main feeds in the ocean currents on Earth, right, and our planet. Okay, and over time, every so ever many thousands of years, one of them shuts down, and it's not the main feed. It's one of the main feeds. Like so basically, when it shuts down and stops flowing, half of the ocean's warming disappears. So we'll just say that. So once that happens, we'll start to cool. We'll start to cool. Start to cool until we see like I want to say more than a mini ice age. It's going to be more than a mini ice age when this channel shuts off, and because of the magnetic shift going on, it's a potential to say that that channel is slowing down because the Earth is heating up. If you take the principles of air and apply it to water, hot water doesn't want to go down. So the hotter the ocean gets, the less that current will get until it just stops flowing. And then that'll cause some kind of reverberation action through the Earth. Will either speed up because it was flowing in the direction, or will slow down because it stopped flowing. I'm not sure exactly what that looks like. Again, and And then, yeah, so at that point, um, there goes the cooling, or there goes the warming of the ocean on the one side, which is the channel that goes up through around the outskirts of England, comes around North America and back down. That channel shuts off every now and again throughout Earth's history. So once that happens, we're gonna deep down into a deep freeze, I guess. That's what I see anyway. Um, so I don't know about this global warming and how it's just gonna get stopped. I don't see it. So anyway, um, yeah, I guess that's all I can throw out there for now. But yeah, the suns are always picking up fuel, and when they get too heavy, they change their poles. Um, so yeah, and all planets are picking up space dust as well, so they're getting heavier over time as well. And as for the center of Earth, we'll just say this about something. I don't know. For those who don't know stuff like that, and I really don't know it inside and out, but I've been studying it for quite a while in my life, and it said something like spin equals wobble, wobble equals the center of the star, the center of the planet, the center of whatever, as long as it's spinning. Okay, the very center. If you pinpointed the exact center, the very center, down to like a centimeter round, we'll just say that, of a planet, and tried to follow its trajectory inside of wherever it's going, there's no exact center. It doesn't stay exact. So, because of that, then you think vibration, and then vibration or friction, which would then equal heat. So, because of its own friction creating its own heat, yeah, it's always in a heating up state. So, um, so the only way we would really somehow lose our friction and gravity would to become a completely solid rock with no heat in the center, as in the moon somehow. Um, and then I would have to go and say something like magnetics. Let's talk about that for 1 second. Okay, so all the planets and all the stars have everything that's in us in them, and I would like to say something that to the effect that they're all of them, everything out there in the universe, I guess. I say universe because, like I said, I don't believe that there's other galaxies out there floating around. Like I say, NASA wants to tell us. Anyway, so there's that. Now all these masses have a magnetic principle to them. Um, they may not have a magnetic field like Earth, but they have magnetics. And if you want to think, well, not if you want to, but I think that I believe it's ferrous metals are magnetic, or it's one of the two, non-ferrous or ferrous, one of the two anyway. I think it's ferrous for sure, in my head anyway. I'll look that up maybe so I can revise this later on. But anyway, all planets have one of the other metals in it, which would make it conducive to be magnetic. So if you think Earth as a big magnet, then structurally imagine the sizes of the other planets, how magnetic they could be in comparison to Earth. Um, then, take gravity out of the picture for a second, and then just start thinking about these planets and stars working magnetically, even though there's gravity as well. So, anyway, that's where I'm at. They say the moon is pulling away from Earth every year or every 10 years or whatever, so however many years, so many centimeters. Well, I'm real sure how they measure that, but that doesn't explain how in the cycle of the moon, once a year or once every so many years, it's closer to the Earth, so it resets itself back out there. So I think somehow that they're convoluting the whole situation to keep people um, from tangibly collecting the truth, whichever that is, really, because who can really say when something hangs around for billions and billions and billions of years? You know, some would have to say trillions of years. So, effectively, outside of something crashing into Earth, um, how is the next trillion years really going to affect my life? Really? So, good luck with that, and y'all have fun and take care. Peace.